Assalamu alaikum wa rahmatullahi wa barakatuh. So today we're going to continue with your exercise 20. Moving on with question 6. Now, for question 6, this is actually something that will be covered in the next topic, but I'm just going to give you the answer for now. Okay. Okay, so some of you may know this already because this is something that you have learned in bio. Okay, so for question 6, where it asks you for the structure involved. Okay, so this involves you knowing some information on proteins. Okay, so let me just... Right. So disulfide bonds between parts of the chain is actually the tertiary structure in the formation of protein. Hydrogen bonds in a beta pleated sheet is secondary. Ionic bonds, tertiary. And the peptide links between amino acids is the primary structure of a protein. Okay, so we'll just leave it there for now and we move on to question 7. Let's see, how do I do this? Okay. Right, so if I draw the structure of question 7, I like to draw it out so that I can see how the structure looks like. That's got a double bond and then a carbon with an NH2. Okay, so that structure looks like that, H2 with a hydrogen on top. Okay, name the 2 functional groups in compound L. Okay, so I will just highlight the first functional group for you is the C double bond C. Okay, please name that structure. And the other functional group is your CONH. Okay, so these are the 2 functional groups that you have to name it yourself, but if you picked it up as we go along, then you should know the name. Okay, compound K can be converted into L. Okay, so you have a CH2CH, COOH. So I'm just going to change this. We've got an OH to form a C double bond C, H, C, O minus, and H4 plus. Okay, so you can see that changes have only occurred on this part of the molecule. Okay, so you don't have to worry about the double bond actually. The double bond is just there as a distraction. So if you look on the drawing here, what exactly is changing is the OH. It turns into a salt. Okay, so COOH is an acid. So you have to think about acid plus something to give you a salt, right? I hope that the answer is obvious to you, that acid will have to react with a base to give that salt. And what specifically the base is, the hint is NH4 plus. Okay, so it must come from ammonia, NH3. So what happens, the lone pair of the base of the nitrogen in ammonia will pick up the hydrogen H plus ions from your COOH. Okay, so that leaves your COOH to become COO minus, and now your NH3 becomes NH4 plus because it has gained 1 hydrogen ions. Okay, so the reagent for step 1 is basically just your NH3. Okay, what other product is formed in step 2? Now in step 2, what you have is a COONH4, and then you form an amide. Okay, so I'm just going to erase that to form C double bond C, C double bond O, sorry, NH2. Okay, so if you can notice what's missing from this structure to the one at the bottom is that everything else on this side stays unchanged. Okay, I want you to take note of that. The moment you go to ONH4, you can see that there's no longer oxygen along this chain. So that means oxygen has left. And your hydrogen, initially you have 4 hydrogen to start with, and then you're left with 2 hydrogen. Okay, so that means 2 of your hydrogen is lost as well. So the other side product in this reaction is H2O. Okay, so again, I repeat, you lost 2 hydrogen from the NH4 plus, and you lose the oxygen here. Okay. State the reagents and conditions necessary to reform K from L. So according to my drawing, this is L, and then this is K. So I have to think of how do I get from L to K. So it looks like I'm reforming the starting materials, which is carboxylic acid. So that means my bond has to be broken at the C single bond N. Okay, and this means hydrolysis of amides. There are 2 types of hydrolysis of amides, either the acid hydrolysis or the base hydrolysis. The easiest one for you to remember is acid hydrolysis. So please choose the reagents and conditions for the acid hydrolysis of amides. Okay. Next, question 8. How many different tripeptides can be made using 1 molecule of each of the amino acids shown? So you have to think about all the possible combination for this formation of the polypeptide. Okay, so the answer, so I'm just going to call glycine G, serine S, and valine V. Okay, so the answer, well, let's work it out first. GS and SG, they too are different things. Okay, the structures of the amino acid, oh, different tripeptides, sorry. So GSV, SGV, GVS, okay, SVG, SGV, and then GVS and GSV, okay. So these are the 6 combinations that can happen. Remember, per amino acid molecule, like for example G, it can form 2 hydration, okay, on the amino side and on the carboxylic side. So in you cannot really determine, is it the carbon terminal of G to the nitrogen terminal of S, or is it the nitrogen terminal of G, and vice versa, okay? But do remember that there are 2 ports, okay? So COOH, this is the C terminal, the NH2 is the N terminal for condensation to happen, okay? Draw the tripeptide serine, glycine, valine, showing the peptide bonds in this plate. Okay, so how do I want to draw this? I like to draw everything with the central carbon, okay, starting with glycine. The central carbon will have COOH. It will also have a nitrogen with 2 hydrogen, and it will have a H. Now the R group, the side chain, I have to follow whatever glycine is, okay? And it turned out that glycine is H. The R group is just H, okay? So nothing difficult for that. Serine, same thing. I start with an N, C, C. One side I know it's of COOH. The other side I know it's NH2. Don't forget the hydrogen on the central carbon. And then the side chain, which is CH2OH. Okay. Next, sorry, excuse me. Valine, same thing. I have my carbon, acid group, amine group, hydrogen on top, and valine, the CH, CH3, CH3. Okay. The R group is the CH3 times 2. Right, they want you to draw serine, serine, glycine, serine and glycine. So I just have to move serine, how do I do this? Serine. How do I move them? Cut, I don't know. Okay, so now serine, glycine, valine in the order that they want you to draw. Okay, so during condensation, you're losing OH from the carboxylic acid and you lose hydrogen from the glycine. Okay, so please draw the correct bond or the correct structure when OH is lost from the acid and hydrogen is lost from hydrogen is lost from the amine group, remembering that there should be a new bond forming between carbon and nitrogen, single. Okay, the other side, same thing, you lose the OH of the COH and the hydrogen of the amine. Same thing, you will release water, H2O, but the new bond is formed between carbon and nitrogen. So if you look at this straight line-ish, okay, you will then later on see it's a repeating unit of NCC, NCC, and NCC. Okay, so I'll leave the drawing for you to draw later. Within tripeptide, which amino acid provides a hydrophobic side chain? So hydrophobic is water hating. It does not reflect, does not react with, does not react. No difference in polarity. In polarity. Okay, so we just have to focus on the, oops. On the R group. Okay, so they want, just choose one gun. Okay, so you can see valine here. It contains carbon, hydrogen bond with no difference in electronegativity, therefore they are neutral. Okay, glycine is also accepted, but the most accepted answer is valine. Okay, moving on. I hope you can keep up. Electrophoresis is a setup that you would use to separate amino acid. Please refer to topic 20. Okay, your nitrogen. How far an amino acid will travel along the electrophoresis? So the two other factors is the size or the MR. The slower it is, the slower it will travel. The charge. Second one is the charge on, oops, the amino acid species. Okay. Charge on the amino acid. Right, question number 10, you may skip it because that is similar to question number 4. Let's have a look at question 11. Now, question 11, before you read the question, I want you to notice that at step 1, we have added this alkyl group. Okay, in step 2, we have added this aryl group. An aryl group is C double bond O C group. And in step 3, you are introducing the nitro group NO2. Suggest the reagent that was used in this step, the only byproduct of step 2. So you want to know the reagent needed for that step. Now, notice that the pink highlighted item is the thing that has been attached to the benzene ring. So if I draw it out, it looks like this, okay? Maybe a little more realistically. Yeah. Okay, so how do we want to attach now? If you notice, this is the CH3. This is the question mark, okay? How can we notice this thing onto the benzene ring? Now, this brings us to the Friedel or Friedel-Crafts reaction, specifically acylation. In a Friedel-Crafts reaction, you need the attachment, whoever that you want to attach, must be attached with chlorine. Okay, and because these methylbenzenes and benzenes are not as reactive, we use catalysts that has the same halogen as your reactant. So that means your catalyst is AlCl3. Okay, suggest the reagent was used in the setup. Well, they don't need you to answer the catalyst. They want you to answer this, which is CH3CO OH or CH3COO. What am I doing here? Wrong. Ayo. CH3COCl. Okay, that's how you write down suggest reaction. Another name for it is ethanol chloride. Suggest the type of reaction that is occurring during both step 2 and step 3. Now, step 2, you're inserting things onto the benzene ring. Step 3, same thing, you're adding nitro group onto the benzene ring. Therefore, this is an electrophilic. Why? Because the benzene is already electron rich. Therefore, it will only attract electrophiles. Electrophilic substitution. You cannot add the double bond onto the double bond in addition terms, but you can only substitute. Okay, remember you lose the hydrogen where you're sitting, where your carbon is sitting on. So the type of reaction, electrophilic substitution. For step 3, state the reagents and conditions needed for step 3. Step 3 is the addition of nitro group. So it's the nitration of benzene. Okay, oops. Right, benzene or methylbenzene is the same. Suggest the structures of the two products formed when A is reacted with an alkaline aqueous iodine. Okay, so this brings back to your iodoform reaction. Okay. I'm just going to draw the rest of the molecule first because that is not involved in the problem here. The problem here is the ketone part, the aldehyde part, this part, okay? Because C double bond O in the, Why I do that? CH3, I meant to write down CH3. Okay, so for an iodoform reaction, you need to have a C double bond O that is attached to a CH3. Okay, so that is the requirement, right? In an iodoform reaction, you will form a triiodomethane. Basically, it is this CH3 being replaced, the H3 is being replaced by iodine. Okay, so that's why you form CI3. Okay, that's the first one. No, CHI3, triiodomethane. Okay, CHI3. The other one would be this whole molecule. Okay, so okay, then you have double bond OH. Okay, plus CHI3. These two answers are your answers. Polymerization again. Okay, so polymerization, if I just introduce you to polymerization, which is the topic that we want to cover tomorrow in the next lesson, hopefully. Okay, so you need to have a monomer that has two functional groups. So in this case, you have a diacid and a diamine. Okay, diphenylamine, right? So how do you draw this? Make sure that the acid is next to the base. COOH, and then there's a COH. Okay, and then you put the amine next to it, a little bit higher. Ayo. Why I do like that? Okay, and then the other one is NH2. I purposely make it like that. And then the other side, you also have NH2. Remember that you can still continue to go on because it is still, wait, how many? Oh, repeat unit, okay? So first you have to think about the condensation reaction. Again, you lose the hydrogen from NH, you lose the OH from the carboxylic acid, okay? So, copy. Okay, so if I just resize that. Okay. And then you see the COH. Because it is a repeating unit, you have to make it as a floating carbon, CO minus, and then so is the nitrogen, hydrogen. Oh, sorry. Okay. What type of polymer is Nomex? You haven't done this. Condensation polymerization. Said the byproduct of the form during step 3. Now you see this? OH and H, that means the byproduct is H2O. Suggest reagents and conditions for step 2. Now, step 2 is turning your nitro into phenylamine. This is definitely in your answer, okay? Phenylamine. Suggest how and why the properties of the polymer might change if some of the diamine monomer were replaced with 1,3,5 triamino benzene. So in the difference between triaminobenzene and the starting material, the one with only NH2, is that now you have more electron-rich, electron-loving components, okay, here, right? And this form a strong hydrogen bond. Okay, so because you have more or stronger hydrogen bond, the material also gets stronger, it gets tougher. Okay, so we say that it gets tougher due to H bond. Okay, you may not know that now. Is that everything? Question 12 is also something that you don't already know. So I will just stop here because some of these questions I want you to cover the next topic first, and then you will come to do this question. Okay, right, so that is all for now. Assalamu alaikum. Thank you, everyone.